7th grade lesson 9.2 is about finding the area of a circle. In the previous lesson, we did circumference, which was the distance around the outside of a circle, also known as the perimeter, right? Perimeter of a circle we call circumference. Circumference. So there's one piece of information. And as you know, when we learned about perimeters of rectangles and triangles and all of those things, followed up soon afterwards was learning about the area, the inside, how much covers the inside of the shape. So we'll be learning about area of a circle today. A couple of vocabulary pieces I want to refresh your memory on too is remember that radius is from the center reaching out with one arm. The radius is half the distance from center to the outside. Then you have a diameter. So this one was radius. Then we have a diameter. That is the whole way across, as if you were standing in the center and reaching an arm out both ways. It is always 2 times the radius. 2 of these, this and then the other way, 2 radii would make a diameter. Or if I know my diameter, but I wish to know the radius, I could take my whole diameter, divide by 2 to get my radius. So it's important that you know how to do that. We were introduced to the number pi in the last lesson. We never really spell out the word pi. We usually use the symbol, and sometimes some of us get lazy and do that. Pi is always, it's an irrational number. The decimal goes on and on forever without repeating in a discernible pattern, but we round it to 3.14, and so we will always substitute the number 3.14 for pi in our 7th grade math. Or you can substitute the fraction version of that, 22/7. That number just gets stuck in your head, the 3.14 or 22/7 as the reference to pi. And it was kind of representing the amount of times that diameter will stretch around the outside of the circle. It comes into play in helping us do the area of a circle. So the first part of the lesson talks about, it's an explore activity, exploring how they come up with the equation or the formula, I should say, the formula for area of a circle. I'm going to tell you what the formula is first, and then I'll take you through that. But just most important is that you work on memorizing the formula for area of a circle. Anytime you need to find area of a circle, you will use A equals pi r square. Pi times 3.14 times the radius, whatever it is, to the second power. I always say it as pi r square, and I always remember it as the lie. It's not true. Pi aren't square, pi are round, like a blackberry pie. For some reason, that works for me to remember it. The area of a circle is always lying to me, then telling me that pi are square, when really pi are round. So if it helps you, great, use that. If it doesn't, then forget I said it. I'll take you through that explore activity. But again, it's leading you to see that that's the formula. It's just trying to help your brain see that that's a formula. But this is the part that you want to make sure that you get stuck into your brain. All right, so they have us exploring the area of a circle, and they have us use a compass, the one that has a pencil on one side and the pointy part on the other, and you can draw a perfect circle. To draw a perfect circle and cut it out. And feel free to do this. You can pause and do this, or use the instructions in your textbook to do this. They say fold the circle 3 times, 1, 2, 3. When you open it back up again, you're going to have 8 wedges. And they say to shade in half of it. So that would be half of our area, right? Our whole area would be the whole thing. So they say shade in half of it. And then they tell you, go ahead and cut out those pieces and line them up so that they're this spiral looking thing with the half of the circle colored in, shaded in, and the other half not. The base and the height of this parallelogram that we have now created relate to the parts of the circle. So we have half of the circumference, right? And then we have our radius value right there. So the base of our parallelogram is half of the circumference. This is now our parallelogram. It came from here, half the circumference of the circle. or pi times the radius. 3.14 times the radius. Remember, because circumference was 2 pi r, so we divide by 2 to get that 2 gone, and then we have pi r. Now the height of our parallelogram is this radius here of the circle, or r. And if we were solving the area of a parallelogram, we would do base times height. So we'll put base times height there. And if we're doing area equals base times height of this parallelogram, let's take the information that we have. The base of this is pi r. And then the height is r. And so I end up with pi times r times r. Let's just clean that up and just have r times r be r to the second. Pi r to the second. Area equals pi r to the second, also known as pi r squared. So that's how they get the formula. You kind of turn the circle magically, cutting it up and everything into this parallelogram, and then we know with area of a parallelogram base times height. So we just kind of manipulated it to work so you could see that that is how we get the formula for area of a circle. So ultimately, it brings us down to this. Area of a circle is pi r squared. Let's see how it works. All right, and so we have a biscuit recipe that calls for the dough to be rolled out and circles to be cut from the old dough. Now I'm hungry. The biscuit cutter has a radius of 4 centimeters. Find the area of the top of the biscuit once it is cut. So, like if we wanted to put frosting on top of the biscuit. No, we wouldn't put frosting on a biscuit. That'd be like a cupcake. Anyways, whatever we wanted to put on top to cover the top with, that's why we would need to find area. For my brain's sake, I'm going to draw a circle. The biscuit. I guess I could have used down there. And it gave me radius of 4, so I'd like to do that for my brain. I like to say, hey, there's your picture of what's going on. You were given 4 centimeters. You were giving the radius r. Okay, so I will use the formula a equals pi r squared. But now I know that the radius is 4. I also know, because I always know, that pi is 3.14. So I have 3.14 times 4 to the second power. 4 to the second power is 16. 3.14 times 16 is 50.24. So the area of the biscuit is about 50.24 centimeters square. And that's all you do. You just plug and play. We take the formula that we'll work on memorizing. Area of a circle is a equals pi r squared. And then we plug in the numbers. Pi is always 3.14. Radius, if we've got it, we go ahead and put that in. And then we calculate using order of operations. Exponents come before multiplication. That's it. That's how you do this. Second part asks you if you're trying to find the area of a circle, and in this case they gave us the radius. What if they gave us the diameter and not the radius? We would want the radius, right? So we would just cut that diameter in half, and that would give us the radius. So you can word that how you want. And then the last part, why do you evaluate the power in the equation before multiplying by pi? Why did we do this before that? Hopefully you recognize your answer, because the order of operations tells me exponents have to go before multiplication, so word that however you want. Let's just practice a few. I have a circle with a diameter of 14 meters, and I want to know the area. And I might just have you practice circumference and area. Let's start with the area, though. Remember, let's just put both formulas there. Circumference was pi times the diameter, because the diameter of the circle will go around the outside of the circle 3.14 times ish. Area is the lie, pi r squared. So we're just doing a lot of plug and play. So let's do the area first. Now, to use the formula for area, I need radius. I did not get radius, I got diameter. Well, if this is me with my 2 arms stretched across, if I put one arm down, then this one is half of 14 is 7. So my radius will be 7 to the second power times 3.14. Order of operations says I must do the exponent first. And then I get my calculator out and calculate 3.14 times 49. And I end up with the area being 153.86 meters squared was radius in meters times radius in meters gives me meters squared. Area is always in square units. They said to round to the nearest tenth. Okay, then 153.9 meters squared, rounded to the nearest tenth place, that place. Just for practice's sake, circumference. So we just found the area, if I wanted to plant seeds in this round garden, how many meters square worth of seeds that I would need. If I needed circumference, if I just wanted to build a fence, let's say, around the outside of my circle garden, then I use C equals pi d as my formula. C equals 3.14 times diameter, which I know, and 3.14 times 14 equals 43.96, round to the tenth place. That would end up being 0.0 because we would carry over, so 44. That rounds to 44 meters. That's not squared because that's just a distance around the outside. It's not meters times meters. It's just meters. So 44 meters is my circumference around the outside. 153.9 meters squared is my area on the inside. And that's how you do that. That's it. Have your calculator handy. If you're in my class, I don't mind you using a calculator on these lessons. And in this lesson, they're not asking you to do circumference. I just did that one for you just to refresh your memory. The more you do it, the more it gets stuck in your head. We can look at one more example. Okay, let's say we have a garden that's round, circular. The diameter of it is 20 yards. I need two pieces of information. I'm going to make you do it twice again. I want to know how much seed I need to buy to cover the whole circular garden. I also would like to know how much fencing I need. So my first question on the amount of seed, that would be area. And the formula for finding area of a circle is the lie. Area equals pi r squared. To know how much fencing I want to put around the outside of it is circumference, perimeter of a circle, right? Circumference equals pi times diameter, because that diameter stretches around 3 and a little more times. Let's just fill in what we know. We know on area that pi is 3.14 times the radius, which they don't give me. They give me the diameter of 20. Well, radius is half of that, so 10 to the second power. Calculate that exponent first. 10 to the second power is 100. Multiply that by 3.14. Nice. I don't even need my calculator. Multiplying by 100. That's going to be 314. Move the decimal twice. One for each zero. 314 yards squared, because we did radius in yards times radius in yards. So yards squared. Areas are always in units squared. If I wanted to know about the fencing, because Mrs. Sanchez is so mean, making me do circumference still, even though the book doesn't say, circumference equals 3.14, which is pi, times diameter of 20. You get your calculator out to do 3.14 times 20, and you will get 62.8 yards. Not squared, it's just yards. It's only going around the outside of it. And so there you go. That's all this lesson is. It's just plugging in the information you get to that r square, and then you can calculate it. You square that, multiply by pi, done. So that's it. Good luck. You can do circumference extra for practice, extra credit if you wish. But this is the focus of this lesson.